So in this video, we're going to get a little more practice verifying identities using some of the new identities that we have derived. So here's the identity to verify. The tip that I gave before was to grab the side that looks the worst, which is the left-hand side, and start with that side. So I'm going to transcribe the 1 over tangent of theta times 1 plus the cosine of 2 theta. And when I verified this identity, there's more than one way to do it, but the first identity that I used was this one: cosine of 2 theta equals cosine squared minus sine squared. So I made that substitution. I said, hey, this is 1 over tangent theta times 1 plus, and then we replaced the cosine of 2 theta here with cosine squared of theta minus sine squared of theta. And then we can use the Pythagorean identity that says cosine squared of theta plus sine squared of theta is 1. And if we subtract sine squared from both sides, we get cosine squared theta is the same as 1 minus sine squared theta. So by manipulation of the Pythagorean identity, I see that I can replace 1 minus the sine squared of theta with a cosine squared of theta right here. So I'm going to get 1 over tangent of theta. And then I'm going to get my cosine squared of theta that I already have, plus 1 minus the sine squared can be replaced with an additional cosine squared of theta. So this is going to be the same as 1 over the tangent of theta times 2 cosines squared of theta. And I want to recognize that multiplication is commutative, it's associative. I can really mess with things, so I'm going to write this 2 out front. I'm going to just kind of pull it over to the front of this expression. And then I want to recognize that the tangent function, so I get 1 over, the tangent can be rewritten as the sine of theta over the cosine of theta, and this is times the cosine squared of theta. And this cosine is going to cancel one of the 2 cosines, leaving me with just 1. So I'm going to wind up getting 1 over 2 sine theta cosine theta. And I'm starting to run out of room, so I'm going to pull this over and up. I would still be working on the right hand side of the equal sign. And now what I want to recognize is that 2 sine theta cosine theta can be rewritten as the sine of 2 theta. And the reciprocal of the sine is the cosecant. So I get the cosecant of 2 theta, which is what we were trying to show. So we were able to show through a sequence of manipulations using established identities that this statement can be replaced with this much simpler statement.